Hello, good evening, everybody. My name is Vishvadeep. I welcome you all on Unacademy Computer Science Channel. In this particular lecture, I am going to talk about AVL tree and more specifically deletion in AVL tree. So, what kind of cases we can have in the deletion of AVL tree, and we will see two more type of questions in AVL tree, that if height is given, then minimum how many number of nodes we can have in an AVL tree, or vice versa. So without any delay, let's start the session. Yesterday we have already covered insertion and creation of the AVL tree using the given keys. If you haven't gone through those lectures, please go through that particular lecture so that you can learn that how the rotations are applied. Four types of rotations: LL, RR, LR and RL. Today is the next session based on the same case. Before we go further, let me introduce myself for those members who don't know about me. My name is Vishvadeep and I am working as a team leader in Unacademy Computer Science branch. I have written the GATE exam multiple times. I am having the rank 19, 119, 440, 682, and there are few more ranks I am having under my belt. Went for my masters to ISC Bangalore, another masters from BITS Pilani. These are the experiences, as you can see, a rich experience in teaching, and these are the courses which I am dealing with on Unacademy's platform. If you guys are actually waiting for learning on this particular channel, we have covered lots of courses, almost all the courses for GATE computer science. So go through those lectures, you will learn a lot. Apart from that, we have another learning opportunity for all of you, and that is on Unacademy's platform. What is that opportunity? Just go to unacademy.com or download the Unacademy Learner app and then search my profile. What you will get on my profile, you will be getting in my profile special classes, and these special classes are absolutely free. If you are the first time learner on Unacademy's site or Unacademy's platform, then you will need a particular code to unlock all the free content, and you can use this particular code VDEEP10. If you use this particular code, you will be able to unlock the free content, including special free classes, including so many tests, quizzes, combat, and so many other options will be unlocked using this particular code on Unacademy's platform. So go and enjoy your free content learning from Unacademy's platform. If you will follow me on Unacademy, you will be getting the notification of my classes, which I am conducting 2 classes per day. One is 12 p.m, another one is 3:30 p.m for absolutely free on Unacademy's platform. What tomorrow I am going to take in these 2 sessions: 12 p.m session will be theory session of revision of pipeline, and 3:30 p.m session will be the questions on pipeline. All the available possible questions we are going to solve, almost 25-30 questions we are going to solve on only pipeline, 3:30 p.m tomorrow on Unacademy's platform. So go and enjoy those classes. Come live and enjoy those classes for free. But again, I am repeating, if you haven't checked out the Unacademy's platform, if you are the new learner, go to Unacademy's site, unacademy.com, or download Unacademy Learner app and use this code to unlock the free content of unacademy.com. If you are waiting for free test series, we have already a free test series rolled out for you guys. This particular test series, you just enroll for it and write the quality test. You will enjoy this particular test series. Why? Just because a really great quality questions you'll be getting over there. Very good evening, everybody. Very good evening. Now, the main point of learning is if you are able to utilize that particular learning to solve the questions or not. Ultimately, the aim is to learn the courses in such a way so that you will be able to solve the questions in the GATE exam, plus you will be able to solve the questions quickly in the GATE exam. For that, you need a cleared version of the concepts. If you have any doubt in query and question, a small doubt also, then not at all possible that you will be able to solve each and every type of question of that particular topic. So you need to have a clear cut understanding of each and every topic. You should have implementation detail, that if this is the concept, how to use it to solve the problem. That implementation detail you should know. Apart from that, you should remember each and every topic so that you can use to solve the question, and all these we can help you in your improvement on Unacademy Plus platform. So if you are coming for Unacademy Plus platform, then on Unacademy Plus platform we give you live classes which are very interactive. Of course, you can listen those live classes in recorded mode also if you miss. You will have weekly tests so that you can understand the implementation of each and every topic. You will be having daily practice problems so that the implementation can be improved even more drastically. You will be having so many doubt solving sessions so that you will not carry any kind of a small doubt about any concept or any topic. All these come under a single package, which is Unacademy Plus subscription. This Unacademy Plus subscription you can take in 1 month, 3 months, 6 months, 12, 18 and 24 months. And if you are using this particular code VDEEP10, this code will help you to get 10% discount. These are the prices after the discount, but if you will use the code VDEEP10, this particular code will help you in multiple things. First, it will give you 10% discount. One second thing, it will give you my mentorship, who has the experience of mentoring so many members, of writing the gate multiple times, cracking it under 1000 multiple times. And third thing is, you can take the support of my entire team. There is a team of 8 members, 8 educators. All the 8 educators will work for your preparation, will give you support for your preparation if you use this particular code VDEEP10. This code is not just a code, it's a connection between your preparation to my team's effort. Remember, every unlock on Unacademy's side, you will have to use this particular code so that you can get lots of benefits. If you are the person who needs a coach, personal coach from Unacademy's side. Why? Just because you are not able to prepare the best strategy, best planning for yourself, then you should go for Iconic subscription. This Iconic subscription has all the facilities, all the inclusions of Unacademy Plus, and apart from that has a facility of personal coach for you. This personal coach will give you study planning so that you can have the customized study plan for your own. The coach will track your performance. You will get study booster sessions. You will be getting the personalized test analysis, means in-depth analysis of your test so that you can improve the next future test, so that you can understand what is the problem you are facing, and based on that you can improve the marks, understanding of the question, and lots of things in your test. Apart from that, you will be getting the preparation study material also, specialized notes and practice sets also. This particular Iconic subscription also you can get using this code so that you can get the discount. VDEEP10 is the code to get the discount. So if you want your rank to be Iconic, use the subscription Iconic, get the subscription done, and enjoy the best quality learning on Unacademy's platform. As you can see, on Unacademy's platform, the top educators of country teaching you in multiple different batches. One more thing, if I told you before or not, that particular thing is, this week itself on Unacademy's platform, 3 new courses are going to start. Yes, 3 new courses are starting, including my course COA, Computer Organization and Architecture. The toughmost course is going to start, and this particular course is going to start probably from 18th of December. I am going to cover this particular course in just 30 days, and complete course including practice, including your doubts, including quizzes and lots of other things. This particular course will be completed. So 3 new courses including my COA going to start in this particular week itself. Take the subscription as soon as possible and enjoy those courses and its learning flawlessly. Now, what is the next thing? The next thing is your approval of learning. If you guys come here live, definitely you will learn a lot, but for that, of course, you should be ready to learn. So I should ask you, are you ready to learn? Are you ready for learning? Are you ready, my friend? If you are ready, let me start the session for the day. Till now, what we have seen in AVL tree, why AVL tree is needed, then types of imbalances, these LR and RL also done. Then after that, I have told you how to insert an element and construction of AVL tree. Still, I don't have many comments in the comment box. अरे type करो, are you ready or not? Yes, no, yes, no. तभी तो मुझे समझ में आएगा कि आप लोग learning के लिए ready है या नहीं. Okay, so all these things are done. Now we are going to talk about deletion in AVL tree. आपको 3 टाइप के deletion पता होंगे in BST. 3 types of deletions we have seen in BST, that the node which you want to delete is having 0 child, 1 child or 2 children. Okay, great. Yes, 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 superb, amazing. That kind of response I want from you. If you are my student, definitely I'll help you with free content also, but for that you need to consistent, you need to be ready always on high energy to learn, so that I can help you in your learning. So in the BST we have seen these 3 cases: case 0, case 1, case 2. Case 0 means the node which I am deleting is having 0 child. Node which I want to delete is having 1 child, and node which I am deleting is having 2 children. So these were the 3 cases for deletion in BST. Deletion in AVL tree is first step same to same. What? The first step is delete the node using BST cases. जो BST के रूल हैं उनको लेके और डिलीशन कर देने का. आफ्टर दैट व्हाट? आफ्टर दैट detect if any imbalance is there. If any imbalance is there. And then if any imbalance is there, then eliminate that imbalance using appropriate rotation. So what you gonna do is, first of all, you are going to delete the node based on the BST deletion rules. आपको पता है BST में deletion के rules क्या हैं? These are the rules. Based on deletion of BST, you delete. After that, you detect if any imbalance. If there is any imbalance, then eliminate the imbalance using the appropriate rotation. Okay, चलिए आगे बढ़ते हैं. Let's see how the deletion happens. These are the 6 cases for AVL tree deletion: R0, R1, R-1, L0, L1, L-1. What these cases are and how these cases will help me to eliminate the imbalances one by one. I will explain every single thing. Just stick to the session and listen. You will definitely enjoy. फर्स्ट ऑफ ऑल R0 केस. अभी तो आपको यह भी नहीं पता है कि इसमें R का क्या मतलब, 0 का क्या मतलब. चलो R तो आप डिटेक्ट कर भी सकते हो, राइट. 0 का क्या मतलब मैं बताऊंगा. I will tell you, just stick to the example. I will need your yes no agreement, some answers from you, so that I can understand you are learning. Okay, so let me take a simplest of example so that I can explain you how this R0 case works. 20, 10, 5, 15 and 30. This is the tree. In this particular tree, first of all, you just check out that the tree is balanced or not. Now when I ask you the question balanced or not, it's your duty of learning, it's your procedure of learning that you reply, so that you will definitely learn more in this interactive manner. So Balanced or not? Let's check out balance factor. What is the balance factor of leaf node? Balance factor of leaf node always 0, 0, 0. What is the balance factor at 10? 1. What is the balance factor at 20? 2 minus 1. So tree is balanced. Yes, balanced. Fine. Now. Let's try to delete a node from this tree. Suppose I have deleted a node from this tree 30. Once I'll delete node 30, 30 is having 0 child. So what changes I'll have to make? कुछ भी खास नहीं. 20's right child becomes null. So 30 will be deleted. If 30 is deleted, the tree becomes like this. 20, 10, 5, 15, right side gone. Now if right side gone, you just check where you have deleted the node. Here you have deleted the node. Wherever you have deleted the node, its parent you check. Same as insertion, the parent at 20 you need to check what is the balance factor at 20. What is the balance factor at 20? Balance factor at 20 will be 2 minus 0, 2. Do we have imbalance? Do we have imbalance? Yes. If we have imbalance, on which node we have imbalance? किस particular node पे imbalance आया? Imbalance at 20. अगर imbalance आया 20 पे, तो ये बताएं कि 20 के किस तरफ डिलीशन किया है, लेफ्ट में कि राइट में? ओनली वन डायरेक्शन, only one side you need to choose which side of 20 you have deleted the node. In the left subtree you have performed the deletion or in the right subtree. So imbalance at 20 because of deletion. Because of deletion. In 20's right subtree. अब 20 के राइट सब ट्री में डिलीशन कर दिया तो इम्बैलेंस आ गया. इफ देर इज एनी इम्बैलेंस, अब हम क्या चेक करेंगे? इफ वी हैव डिलीटेड इन राइट साइड, विच साइड विल हैव मोर नंबर ऑफ नोड्स, मोर हाइट, विच साइड विल बी हैविंग मोर लोड? अगर राइट साइड से डिलीशन किया तो लोड कम हुआ राइट साइड में, एंड इफ इन द राइट साइड वी हैव डिलीटेड एंड लोड हैज बिकम लेस, मींस हाइट हैज बिकम लेस, imbalance has occurred. Because of that, in the left side we will be facing more height of the tree, we will be having more height of the tree. If right side deletion, left side में more height. If left side में more height, then we need to check. We need to check the balance factor of 20's left child. We need to check the balance factor of 20's left child. What is the balance factor of 20's left child? यहाँ पे चेक करेंगे कि बैलेंस किस वजह से है. लेफ्ट साइड में ज्यादा नोड है इसलिए, या राइट साइड में ज्यादा नोड है इसलिए. व्हाई वी हैव इम्बैलेंस एट 20? बिकॉज लेफ्ट साइड मोर हाइट इज देयर और राइट साइड मोर हाइट इज देयर. व्हाट इज द बैलेंस फैक्टर एट 10? लेफ्ट चाइल्ड ऑफ 20, 0. So if right side we have deleted from 20, remember we need to check out the balance factor at left child of imbalanced node. Balance factor of left child of imbalanced node. Left child of imbalanced node 20. So if balance factor of left child of 20 is equal to how much? कितना है? Equal to 0. So here the case becomes R0 case. Case is which one? R0 case. समझ में आया R0 case कैसे बना? If you have deleted the node from imbalanced nodes right side, check out the left subtree's balance factor, left child balance factor, it is 0, then R0 case. अब अगर R0 case है तो आपको अप्लाई करना है रोटेशन RR, नो LL. R0 अगर केस है तो सॉल्यूशन क्या होगा? LL. So solution of this R0 case is LL rotation. And now you know that LL rotation is what? How LL rotation will be done? Single right rotation this way. Let's do LL at 20. If we will do LL at 20, what happens? 10 will go onto the root. Right side 20. Left of 10 is 5 and right of 10 becomes left of 20, 15. This particular tree is now balanced. No problem at all. This tree is balanced now. Just check out if you understood this method or not. अगर आपको method समझ में आई है तो let's go and let's check out the next particular case. If you understood this, I will quickly cover R1 case. Deletion in right side, left subtree's balance factor is 1. How we will do that? R1 case. Quickly I will cover this. 20. Right side, suppose 30. Left side 10 and 5. This is the tree. Suppose from this particular tree, which is of course balanced, balance factor here is 0, here is 1, here is 1, here is 0. Let's delete a node which is 30. If you have deleted the node 30, the tree becomes like this: 20, left side 10 and left side 5. This tree now becomes imbalanced. Why? Just because balance factor at 20 is equal to 2. That's the rule, Vishvadeep. That's the rule. Somebody asked, sir, LL क्यों लगाया? ये रूल है. लेफ्ट साइड में अगर ज्यादा बैलेंस, ज्यादा नोड है, ज्यादा हाइट है, if you have more heights in the left side, shift it into the right side. How can you shift in the right side? The shifting in the right side will be done by single RR or LL rotation, right side rotation. Right? So rotation is very simple. अगर ऐसे rotate करेंगे this way, then 10 will go up, 20 will come down, 10 will go up, 20 will come down. 10's left is as it is 5 and then 10 का right जो है left में आएगा 15 किसके? 20 के. Why? Just because 10 के right में तो already 20 है, अब यहाँ तो रख नहीं सकते. So what we will do? Greater than 10, less than 20. Greater than 10, right side of 10, left side of 20, we will keep 15 here. R1 case, if I have deleted the node by 30, after deletion of 30, the tree becomes like this. Balance factor at 20 is 2. Yes, imbalance. Where is the imbalance at 20? So I am writing imbalance at 20. Why we have imbalance at 20? Because of the deletion. Because of deletion. Which side you have deleted? 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 You have deleted in the right side. Deletion in right subtree of 20. Right subtree of 20. If right subtree of 20, in right subtree of 20 you have deleted, then you need to check out the balance factor of left subtree or left child. Balance factor at left child of 20. Balance factor of left child of 20. कितना है left child पे 20 के balance factor? Is equal to how much? At 10 you just check out balance factor. यहाँ पे कितना है balance factor? 1. So it is 1. If it is 1, then the case becomes what? R1. If it is R1 case, then the rotation again is same LL rotation. LL rotation. LL rotation same to same, single right rotation like this way. Rotate it. LL at 20. LL at 20. So after rotation, the tree becomes like this. 10 goes up on the root, left side 5, right side 20. अभी आप बोलोगे सर इन दिस केस वी कुड अंडरस्टैंड यस सिंगल राइट रोटेशन कुड वर्क. अभी आप पूछोगे सर यहां पे तो एलआर भी तो लग सकता था. वी कुड हैव अप्लाइड एलआर आल्सो हियर, एल एंड आर, दैट विल आल्सो वर्क. नाउ आई विल आस्क वन पर्टिकुलर क्वेश्चन. इफ यू विल स्टडी 1 hour एंड योर वर्क इज डन, व्हाई शुड यू स्टडी 2 hours? अगर एक पर्टिकुलर रोटेशन में काम हो जाता है तो 2 रोटेशन क्यों लगाने? You know that LL and RR are single rotation, but LR is double rotation, right? So why to apply double rotation if single rotation works? If single rotation works, why to apply double rotation? That is what I told you. I hope you guys are understanding this point. Yes or no? Yes. So that's why for R0 case we are applying LL rotation. Okay, just because it is single rotation, and if in the single rotation we are getting the solution, why should we go for double rotation? Next one, R minus 1 case. Let's try to understand R minus 1 case quickly. So we have the node like this, 20, its left 10, right side 15, and right of 20 is 30. This is the tree. Of course it is balanced tree. You can see balance factor here is 0, leaf node 0. What is the balance factor at 10? 0 minus 1 minus 1. Here balance factor at 20 will be 1 2 minus 0 1. No problem at all. Suppose in this particular tree you have deleted 30. If you have deleted 30, then let's delete 30, the tree becomes this: 20, 10 and 15. Now what is the balance factor at 20? The deleted node's parent here. What is the balance factor here? Balance factor here is 1 2 minus 0 2. We have imbalance at 20. We have imbalance at 20. Imbalance at 20. If we have imbalance at 20, why we have imbalance? Because of deletion. Because of deletion. In which subtree we have deleted from 20? In right subtree of 20. If right subtree of 20 has deletion, we need to check the left child's balance factor. 20 का left child 10. What is the balance factor at 10? Balance factor at 10 will be minus 1. So balance factor at left child of 20 is equal to minus 1. So the case becomes which one? R minus 1. Case is R minus 1. If it is R minus 1 case, you need to apply now which rotation? LR. Solution is LR rotation. And LR rotation is not single rotation this time. आपको पता है? Yes or no? You know, right? LR rotation is single rotation? No, it's a double rotation. It's a double rotation. तो double कौन-कौन से rotation करने हैं आप जल्दी से बताओ. If you have seen my yesterday's lecture, you should know that. Which rotation? First of all, which rotation on which node? Which node? LR rotation. First one LR rotation में second character RR at RR at what? Left child of 20 means RR at 10, and after that LL at imbalance node 20. RR means single left rotation, this one. So first of all, let's apply RR at 10. RR at 10, if you will be doing, then 20, left side 15 and left side 10. कैसे किया? ये 15 ऊपर चले जाएगा, 10 इधर आ गया. Then next one is what? Okay, इसको सर्कल में लिखते हैं, थोड़ा ज्यादा क्लीन दिखेगा. Next one is LL at 20. Let's do LL at 20. LL at 20 means single right rotation like this way. 15 will be root, left side 10, right side 20. Got it? And this particular tree is now balanced. Right? Okay, so I'm going back, and on this particular here I am writing the cases. For R0, which rotation you have applied? LL. For R1, which rotation you have applied? Again LL. For R minus 1, which rotation you have applied? LR. Now I am going forward, and we will explore these left side deletion also. 3 cases for left side deletion also. जल्दी से quickly we will observe. जल्दी से हम उसको भी observe करेंगे. Okay, so left side deletion this time. Let's take the tree first. 20. 10. 30. 25 and 35. Very good evening, very good evening, very good evening. Welcome everybody, welcome. Chali. So if this is the tree, let's check out that if the tree is balanced or not. Balance factor here 0, balance factor here 0, balance factor here is 0. Leaf node 0, 1 minus 2 minus 1. No problem, balanced, yes. Let's delete a node. Balance था तो एक node delete कर दी. Which node we will delete? Left side we will delete now. 10. We will delete 10 from here. If we will delete 10 from here, after deletion of 10, the tree becomes like this. 20. Left side 10 gone. Right side as it is 30. Left 25. Right 35. Now we will check जहां deletion किया उसका parent. Wherever you have deleted the node, its parent 20. You just check what is the balance factor at 20. Balance factor at 20 is what? 0 minus 2 minus 2. Is it the range? Is it in the range? No, it's not in the range. It is not in the range. So imbalance, yes. Where? On 20. So I'm writing that statement here. Imbalance at 20. Why? Because of deletion. Because of deletion. Pum 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 para. Because of deletion. Which side? Which side deletion? From 20's left subtree you have deleted or right subtree? Because of deletion in left subtree of 20. I know it's too cold at your place that you cannot even take your hands out. You are sitting like this way. But still, for learning, you can take your hands out and type. Or if you are using your mobile phone, you can go inside your quilt or blanket or something, and you can still chat so that I can get your messages in the comment box. Imbalance at 20 because of deletion in left subtree of 20, and we need to check out now. अगर left में delete किया है, if you have deleted in the left subtree, which side balance factor you are going to check? Which side balance factor you are going to check? Which side balance factor you are going to check if you have deleted in the left? Right child. 20 का right child balance factor. 30's balance factor you need to check. What is the balance factor at 30? 0. So, and balance factor at 30 is what? Balance factor of right child of 20. Of right child of 20 is equal to 0. Here you will get a particular case L0. So case is L0 केस. अगर केस L0 है, इसका सॉल्यूशन क्या होगा? In the case 0 you are going to apply RR rotation. Solution is RR rotation. सॉल्यूशन है भैया, सोल्यूशन नहीं है. हाँ ठीक है, RR rotation. बढ़े आगे, आर आर रोटेशन करके देखते हैं. आर आर रोटेशन इज सिंगल लेफ्ट साइड रोटेशन हियर. So RR at 20 we apply. RR at 20. Let's do that. Let's do that. 30 will go up. 20 in the left. And then 30's right will be as it is. 35. What about this left of 25? Oh, sorry, left of 30, left of 30, left of 30 already blocked. So we should keep it in the right of 20. Here, 25. Okay, fine, got it. This is the balanced tree after the rotation or not? Yes, balanced tree. Here balance factor 0, here balance factor 0, here balance factor -1, here 1 2, -1 is 1. There is no any problem, balanced. L0 case explained and you also understood, I guess. Next one, this one L1 case. Quickly we will cover remaining cases. जल्दी से cover करते हैं सारे cases को. So we have a tree like this. 20, left side 10. इसको निपटाना है, हाँ 10 को निपटाना है. 30 and here we have 25. So this is the balanced tree. Yes, balance factor here 0. Here 0. Leaf node पे balance factor हमेशा 0. What is the balance factor here at 30? 1 minus 0, 1. Balance factor at 20 is 1 minus 2 minus 1. Now let's try to delete a node which will make our tree imbalanced. We are going to delete 10. निपटा दो उसको. So we will delete 10. When we will delete 10, 20 का लेफ्ट में कुछ भी नहीं, नल. रिमेनिंग ट्री एज इट इज. बचा कुचा इतना. अभी लेट्स चेक आउट वेर एवर यू हैव डिलीटेड इट्स पेरेंट. यू जस्ट चेक 20 पे बैलेंस फैक्टर चेक करो कितना आएगा. व्हाट इज द बैलेंस फैक्टर एट 20? लेफ्ट साइड 0, राइट साइड 2 -2. इफ बैलेंस फैक्टर इज out of the range 1 0 -1, in that case we need to check out key what is the case. For case what we are going to check out, I am writing entire statement for you guys so that you can get a proper note. Imbalance at 20 because of insertion. ना deletion, सोना नहीं है. Deletion in where? In 20's left child. In 20's left subtree. अगर 20 के लेफ्ट सबट्री में डिलीशन हुआ है, then we need to check out balance factor of right child of 20. Balance factor of right child of 20 कितना हो जाएगा? Balance factor of right child of 20 is equal to, look at this, right child of 20 30. यहाँ पे balance factor आएगा 1. So case is L1. Left deletion L1. If it is L1 case, क्या लगता है आपको? क्या लगता है पांडे जी? बजाओ सीटी और जल्दी से आंसर बताओ. विच रोटेशन? RL रोटेशन. सॉल्यूशन फॉर दिस वन इज RL रोटेशन. RL rotation is again not a single rotation, double rotation apply करना पड़ेगा. First rotation is LL. LL at right child of 20 which is 30 and then RR at imbalanced node 20. Got it? चलिए अप्लाई करते हैं एक एक करके. पहले LL at 30. LL at 30. LL means single right, this rotation. After this LL at 30, 20 will be as it is on its position. Here 25 will go up and its right becomes 30. After that we will go for RR at 20 like this way. RR at 20. Let's go. How we will go with this one? 25 will be reaching to the top. Left में आ गया 20, right में आ जाएगा 30. Hope you understood that. Hope you understood that. Now this particular tree is balanced. जी हाँ, बिल्कुल balanced है. आपके दिमाग की तरह नहीं कि सर आज पढ़ने का मन नहीं करा कल करेगा, फिर आज नहीं कर रहा कल करेगा. ऐसे imbalances नहीं चलते हैं. Tree is balanced now. This is the time when your character will prove that you have quality to get success or not. If you have quality to get success, then you will not quit the preparation, or you will not go, or you will not let yourself down in this highest level of preparation time. Last 1.5 month hardly remaining. In this 1.5 month, if you will be preparing your highest level mentally, physically, then definitely you will get better in your this career. Chill. L minus 1 case. Let's see quickly how L minus 1 case works. 20, 10, 30 and 35. This is the tree. Of course it is balanced. Leaf node 0 balance factor, 0 balance factor. Here is minus 1. Here is also minus 1. If suppose from this tree we have deleted a node 10. What happens if we delete the node 10? 20 पे imbalance आएगा. Yes, Vishvadeep. Exactly. 20, 30, 35. Wherever you have deleted its parent 20, you just check what is the balance factor at 20. Balance factor at 20 is 0 minus 2 minus 2. We have imbalance at 20. Imbalance at 20. Why? Because of insertion. है ना? Insertion because of deletion. In which side of 20? In left subtree of 20. If we are deleting in the left subtree of 20, check out the right child's balance factor. 20 के right child का balance factor, 30 का balance factor is what? Balance factor here is 0 minus 1 minus 1. Balance factor at right child of 20 is equal to minus 1. In this case, the case becomes L minus 1. अगर L minus 1 case है, what is the solution? Solution is single rotation here, RR. कर दीजिए apply RR rotation. RR rotation here. Single left rotation at 20. Let's do that. So 30 will go on the top. Left side of 30 is 20. And right side of 30 is 35. Tree is of course balanced. Balance factor here 0, here 0, here 0. All these cases we are done with. चलिए, तो ये सारे केसेस के यहां पे रोटेशन फिर से लिख देता हूं. L0 केस, which rotation? RR. L1 case, RL. And L minus 1 case, RR. So these 6 cases, there are 6 rotations. Just remember, you can solve any deletion question. अब ये है ट्री. इस ट्री को हमने कल बनाया था इसी सेशन में, यहीं पे. we have seen this particular tree construction yesterday only. We need to delete the node. First of all, the very first value is 1. If you delete 1, then 2, then 11, then this. Deletion is simple, which I told you. First delete. If there is any imbalance, then check out, eliminate, rotate, and then go for the next step. Fine. So first of all, let's delete. First value 1. When you have deleted 1 from here, what happens? What happens? Check out the balance factor at 2. Is there any imbalance at 2? What is the balance factor at 2? What is the balance factor at 2? 0. What is the balance factor at its parent? Again, 1 minus 2 minus 1. What is the balance factor at 13? 0, 1, 2, 0, 1, 2. Okay, 1, 2, 3 or 1, 2, 3, whatever, it becomes 0. Is there any imbalance after deletion of 1? Is there any imbalance after deletion of 1? No. No? Okay, fine. So if no any deletion, no any imbalance is there after deletion of 1, then I am drawing the tree once again. Okay, let me not redraw. If you understood this, no, then let me clear this. Let me go back, and in the same tree next key also I am deleting 2. Let's delete 2 then. When I am deleting 1 and 2 both, what happens in this case? 5's left subtree is nothing. 5 left subtree is nothing, null. Check out what is the balance factor at 5. What is the balance factor at 5? 0 minus 1, 2 minus 2. Do we have imbalance at 5? Yes. Now check out which case. पहले देखेंगे किस side deletion किया, left कि right. Which side of 5 you have deleted the node? 2 got deleted in the left subtree of 5. Right? So after deletion of 2, what kind of case we will have? Of course, deletion of 2 will lead us to have the case L, left side deletion. If left side deletion, what is the right child of 5's balance factor? 5k right child balance factor at 8 is what? Oh, yellow color to dikhega bhi nahi. What is the balance factor at 8? 0 for L0 case. For L0 case, which particular rotation? ये देखो L0 case RR rotation. L0 case RR rotation. Let's do RR. RR at 5. RR at 5. Let's do that. So once we will do RR at 5, 13 will be as it is. Its right subtree will be as it is. 25. Left 15. Right 17, 25's right as it is 29, in the left we have 27, right 40. Look at this 8 will come up, left will be 5, 8 ka right as it is 11, left of 8 will go in the right of 5, which is 6. Now the tree is balanced. Tree is balanced. Tree is balanced. Fine. If you are fine with this, after RR at 5, we have got this particular tree. Now from this particular tree, we are gonna delete next key. Okay, I am drawing the tree once again here so that I can explain the deletion. 13, left side 8, 5, 6, 11, 25, 15, 17, 29, 27 and 40. From this particular tree now you are deleting 11. If you are deleting 11, this one, at 8 you will check out the balance factor. What is the balance factor at 8? 2. Yes, Utkarsh, it is live. It is live. You are deleting 11 in the right side of 8. Fine. If you are deleting 11, 8 is having balance factor 2. Balance factor 2 means we have imbalance at 8. If we have imbalance at 8, just check out which side of 8 you have deleted. Right side means after deletion of 11, we will be having a case of L. sorry, R. In the right side you have deleted R. Now in the R left side balance factor you just check. 8 का left side का balance factor कितना है? यहाँ पे 1 की -1 -1 0 -1 -1. So case will be R -1. For R -1, what kind of rotation at 8? LR. LR at 8. LR at 8 is not a single rotation. It's a double rotation. First of all, second character RR at left child of 8, which is 5. And after that, we are going to go LL8. Let's do these two rotations. पहले rotation करते हैं RR at 5. If you are doing RR at 5, RR at 5 means this way. The tree will be like this: 13, 25, 15, 17, 29, 27, 40. And left side 8, 6 will go up and 5 will be down. After this, on this particular tree, you're going to apply what? LL at 8. LL at 8 means this way. So the final tree after rotation will be 13 in the left, 6 left, 5 right, 8, 25, 15, 17, 29, 27 and 40. Tree is balanced now. From this particular tree, now we will have to delete few more nodes. यहाँ से delete करेंगे. Okay, so let me draw the same tree again on the next page so that we can understand how the deletion happens. Okay, next is 17 deletion. Fine. चलिए जल्दी से मैं tree बना लेता हूँ. 13, 6, 5, 8, 6, 5, 8, right side, 25, left side, 15 and 17, 29, 27 and 40. Okay, let's delete next key, which is 17. When we delete 17, at 15 you check balance factor 0, no problem. At 25 you check balance factor 1 minus 2 minus 1, no problem. At 13 you check 1 2 minus 1 2 3 minus 1, no problem. After deletion of 17, no any imbalance. Then next you delete 5. After deletion of 5, you just check at 6 what is the balance factor? 0 minus 1 minus 1. Balance factor at its parent 13, 1 2 minus 1 2 3, no problem. Then after that delete 8. Once you delete 8, what is the balance factor at 6? Balance factor at 6 is 0. Balance factor at 13 is 1 minus 1 2 3. Balance factor at 13 is equal to minus 2. 1 minus 3 minus 2. Now if it is minus 2 at 13, you just check from 13 which side you have deleted. From 13, 8 comes in which side? Left subtree. Left subtree. So deletion of 13 will have a case of L. Left subtree, what is the right subtree's balance factor? At 25, what is the balance factor? Balance factor at 25 is 1 minus 1, 2 minus 1. So the case becomes L minus 1. When L minus 1 case is there, for that you need to apply RR rotation at 13. Let's apply RR at 13. When you apply RR at 13, the tree becomes like this. 25 will be on the root, left side 13, its left is 6, right side of 25 will be as it is. Sari greater keys will be in the right only. 25's left will become 13's right, 15 here. This is the tree. Oh, I have deleted what? I have deleted 8 only. After deletion of 8, L minus 1 case. After deletion of 8, L minus 1. Now next is deletion of 13. If you are deleting 13, you can either use in order predecessor or successor. If I haven't mentioned, I am using in order successor. So after deletion of 13, in order successor 15 will take place. So after deletion of 13, my tree will become like this: 15, 6, 29, 27 and 40. Is there any imbalance after deletion of 13? No. Then next is 6. You delete 6 also. If you delete 6 also, there is no any imbalance. You can check out 15 पे balance factor 0, 25 पे balance factor 1 minus 2 minus 1. No problem. Then last you delete 15. When you delete 15 also, you get imbalance at 25. What kind of imbalance? 0 minus 2, balance factor is minus 2 here. Which side you have deleted? Left side. So after deletion of 15, you will be having a case L, and right side balance factor here is 0. So L0 case after deletion of 15. So L0 case means single left rotation or RR rotation. Let's apply RR at 25. RR at 25. You will be having 29 on the root. Let me take blue color only. 29 will be on the root. Left side 25. Right side 40 as it is. Left of 29 will become the right of 27. This will be your final tree. After entire deletion. I hope you all understood this particular concept of deletion. Fine. Okay. Now the next type of questions are very, very simple. What it says, the minimum number of nodes in AVL tree. LV आ गया यार ये. AVL tree. Oh, pen. AVL tree. With height h is what? Minimum number of nodes we want in an AVL tree. If we want minimum nodes, then what should we take? We should keep one side more nodes, other side less nodes. We should keep one side more number of nodes, one side less number of nodes. So that only we can have a balanced tree also, and the height also fine, and minimum number of nodes. Fine. Now, if minimum number of nodes we want to calculate in an AVL tree, what we need to do is we need to take a particular tree with height h in such a way one subtree will have more number of nodes and one subtree will have less number of nodes. Means left subtree can have or right subtree can have more or less. किधर भी any side you just take, but one side you should take more nodes, one side you should take less nodes. So if you have h as the height of entire tree, what is the maximum height difference allowed? What is the maximum height difference allowed in an AVL tree? One, either the height more should be in the left subtree or right subtree, whatever. So I am giving you a particular hint here. The hint is, if I want to construct an AVL tree of height h which should have minimum number of nodes, so one side of the root I should have an AVL tree of height h minus 1 and other side I should have the AVL tree with height h minus 2. एक तरफ हाइट h minus 1 का AVL ट्री, एक तरफ दूसरी तरफ हाइट h minus 2 का AVL tree. What is the maximum height of the trees, subtrees here? What is the maximum of h minus 1 and h minus 2? Maximum is h minus 1. h minus 1 plus 1 will be the height of entire tree. तो height भी निकल जाएगा and we will be having minimum nodes in AVL tree. So how we are approaching minimum nodes in AVL tree? One side you keep less height, one side you keep more height. Of course. आप बोलोगे सर लेफ्ट में ही क्यों h minus 1 रखा? अरे उल्टा रख दो यार, उल्टा रख दो, कोई प्रॉब्लम नहीं है. One side, left side you can take h minus 2, right side you can take h minus 1. That is also fine. One subtree should have one less height than the other subtree, which is allowed in AVL tree. So we need to construct one side AVL tree of height h minus 2, one side AVL tree of minimum nodes with height h minus 1 plus one node and you will get an AVL tree of height h. चलिए तो बेस केस पहले बात करते हैं. What are the base cases? Base cases are two. What is the single node height? 1. Single node height h equals to 1 single node. This is the base case. And h is equal to 2. Base case is this tree or this tree. Minimum nodes. So with height h equals to 1, what is the minimum node? 1. What is n minimum? Minimum number of nodes is 1. With height h is equal to 2, what is n minimum? Answer is 2 nodes. Now based on this, we will construct the next cases. कैसे? Suppose I want h is equal to height 3. Height 3, minimum number of nodes. So from here, one side you need to have minimum node with single height. One side you take AVL tree with minimum nodes with height 2. So you can take this or this also. Means you can take one side height h minus 2, one side height h minus 1. Or left side you take height h minus 2 and right side you take height h minus 1. Or in fact left side you can take height this one and this one. All four will be height h is equal to 3 minimum number of nodes. Fine. Now based on that, we are going to have a particular table. So if height if height is given, then we are calculating minimum number of nodes with that height in an AVL tree. So if assuming height is 1, number of nodes are 1, base case. If height is equal to 2, number of nodes are 2. These are the two base cases. Now for further, next height is equal to 3. One side you have with height 1 node, other side you have with height 2 nodes, total 3 plus root, total 4 nodes. Total 4 nodes. How can you say 4 nodes? One side height h minus 1, one side height h minus 2, whichever side you want. One side AVL tree of minimum nodes with height h minus 1. One side minimum node AVL tree of height h minus 2. कितनी nodes हैं दोनों में? Calculate कर लो. 1 plus 2 total 3 and the root is 1 node, 4 nodes total. If you want to take height 4 में कितनी number of nodes होंगी? One side h minus 1 4, one side h minus 2 2, 4 plus 2 5, sorry 4 plus 2 6 plus 1 7 number of nodes minimum with height 4. Then for 5 it should be 7 plus 4 11 and plus 1 2 12. For 6 12 plus 7 19 plus 1 20 nodes and it goes on. So can I write a simple formula here? If I want to have minimum number of nodes of height h in AVL tree, it is equal to 1 when height is equal to 1, height is equal to 2, it is 2, and when height is greater than 2, what we are going to say is n minimum with height h minus 1 plus n minimum with height h minus 2 plus 1. Next, ये देखो, ये वाला height h के साथ में minimum number of nodes this. अगर definition, if the definition is given single node height 1, then this particular thing works. If in the question given that with the single node tree's height is 0, height of the tree is 0, then instead of this my formula will become when height is equal to 0 1 node, when height is equal to 1 2 nodes, when height is greater than 1 then this formula. So you can tune this particular formula for other particular definition also easily based on your understanding. Based on this particular concept, there was a question in GATE exam. Yes, GATE exam में with height 3 minimum number of nodes in an AVL tree is what? If the tree's height is this much, or with single node height is this much. Like this way, there was a question in GATE computer science. You can solve that question easily. Now you have, based on the same thing, you have another question. This, the maximum height of an AVL tree with 7 number of nodes is how much? That is your homework GPK question. Try and understand how to solve such questions. You will definitely get an idea. It's a homework question. Solve this particular question based on whatever we have just now understood. ओके फाइन, चलिए तो आज का ये AVL ट्री इज डन. Now we will start from tomorrow graph. So we will see what kind of different representation of graph we can have, and then we will quickly jump to BFS, which is breadth first search. And after that, next day we will talk about DFS, and after that we will start hashing. So very few topics left. Hashing is important, so don't miss. Graph is little bit tricky, so don't miss, just because if you will miss a small trick, you will, or you may miss a important question in GATE exam. If you are learning from this particular channel is providing you complete package in terms of 8 educators working here. There are few playlists which are complete here. Go and check out COA. I only taught 53 lecture series. It is complete for GATE syllabus. Every single thing is available. Discrete math complete, theory of computation by Mallesham sir complete, computer network by Pankaj sir complete, machine learning, operating system, and few more courses are going on regularly live on this particular channel. So you will be able to learn lot from this channel. Stay tuned, learn, keep learning, keep watching previous lectures, keep watching live lectures too. We are working a lot for you guys. If you want the PDF of live lectures, go to this particular Telegram channel and you will get all the PDF of each and every lecture. Apart from that, you will be getting all the announcements and their links on this particular channel. And if you want to be connected with us, go to these Facebook pages. These Facebook pages are the best way to be connected with us, with our team. If you have friends in other domain, let them know that we, our team, our entire family is providing free education in other domains also. For electrical, we have Creatrix channel, ECIN also same Creatrix channel. For GATE, MEPIXC, we have Unacademy GATE this channel. Mechanical and all, civil के लिए this channel. Telugu language, SSC JE channel, and general study RRB SSC channel. We have the channel, your own channel, Unacademy Computer Science, also for the computer science related problem. We are providing lots of solution here. Apart from that, we are providing lot free content on Unacademy's platform also. So Unacademy is India's largest online platform for learning right now. Take advantage of lots of free content which we are providing, so that you can learn and enjoy the best quality learning. If you haven't subscribed this particular channel, please do it. Turn on the notification so that you can get the notification of all my classes. If you have liked the video, please like the session and keep sharing these sessions, playlist and channel with all of your friends. If you enjoy our lectures, share it on your social media, on your stories of the social media, status of the social media too, so that maximum number of students can join us live here for the maximum quality learning. Happy learning, that is my favorite quote. Keep learning happily, we will make your learning happy. Thank you so much for giving your precious time here. 8:15 another session is going to start for TOC, same channel. Stay tuned, don't go anywhere. कहीं नहीं जाने का. 5 मिनट में एक नया सेशन स्टार्ट होने वाला है. I will see you soon in the next class. Till then, have a nice remaining day. Bye bye.